for...
Let me just... Awesome. So let's kick off today's session. Good morning and welcome everyone to our Tech Day edition. Today we are joined by AWS, who is going to take us through building a hybrid network connectivity with AWS. I'm Yolandi Klute. I am from the NAB Africa team. And today I am joined by Peter and Kavir from AWS, who will be our presenters for today. So just a few navigation tips and tricks. So at the, well, not tips and tricks, but so at the bottom of your screen, you should be able to see the Q&A section where you are welcome to send through some questions for Peter and Kavir. We also have the chat function. You are more than welcome to give us a good morning and, you know, engage in discussion if you'd like. And that is basically it. So over to you, Peter. Thank you so much for joining us this morning. We are now going to give you all the attention you need.
Awesome. Thanks, Yolandi. Great. So my name is Peter Littlefield, as you can no doubt see on the Zoom session. I am a Senior Solutions Architect with AWS, and joining me today is Kavir Hari. Kavir is also a Senior Solutions Architect. I'll give him a chance to introduce himself in a moment. A little bit of background about me. I have been in the kind of solution architect space for many, many years. I'm a very old man. About probably more than 15 years now. I worked at a systems integrator and an ISP. That was my kind of background and history. And around 3 years ago, I joined AWS, which is where I've been since. A few things about me. I'm an absolute geek. Contrary to my preachings around cloud, if I had to move my camera around, you'd see an actual server rack in my study with me. I have numerous Raspberry Pis scattered around, and I'm also quite a stereotype in terms of I'm a cat person. So when people joke about half the internet is cats, I contribute to that. But enough about me. Before we get started, I'm just going to hand over to Kavir quickly, and he'll introduce himself. We're going to kind of tag team this presentation a little bit. Kavir, over to you.
Hey, everybody. How are you doing? Good to meet everybody. So like Peter said, we are both solution architects. I think we both have a deep history in the telecom space, working for different ISPs. But fantastic to meet you all today, and excited to kind of tell you guys around AWS and what we consider hybrid networking. Thanks. Over to you, Pete.
Cool. Thanks, Kavir. Great. So what we're going to be covering today is pretty much what you see on the screen. So it's not going to go super deep, but we're going to kind of cover kind of from the start. How would you think about leveraging AWS in terms of hybrid architectures? And so I'm going to jump right into it with a few stats. So what we're seeing in terms of kind of market data, you know, in the 17 years that we've helped tens of thousands of customers move to the cloud, is that the majority of enterprises really do have a cloud-first strategy. Around 88% of those enterprises. But the reality, though, is that we really are just getting started. So many of the conversations that Kavir and I have relate to migrations or starting out in AWS. And the data, again, reflects that, right? With, you know, kind of 86% of the infrastructure spend still being on premises. So what does that mean in terms of kind of connectivity and networks? What that means is that we do need to consider and bear in mind that traditional enterprises are complex, right? So depending on the type of industry, the type of organization, you might have different physical sites. You may have lots of data centers, you may have branch offices, remote workers nowadays is a big thing. You'll have warehouses. And so today, enterprise networks still are complicated, and we do want to make sure that all of these are connected together in a secure and scalable manner. And that in itself can be a challenge, right? Along with that, we have applications which are being migrated to AWS. So you're building applications on AWS while you still have a lot of on-premises presence, and it's a journey. It takes time to move those workloads entirely onto AWS and become cloud native. And until then, we need to talk about hybrid connectivity. And so how can we connect all these things to AWS from all of these different types of kind of scenarios on premises environments? So the vision is pretty simple, is that AWS becomes the hub. AWS connects you to your on-premises architecture, whether it's your factories, your data centers, branch offices, and that AWS can be the glue which connects all those sites together. So if you're bringing up a new factory and want to connect it to your data center, you can use the AWS global backbone to effectively kind of transit that through to your on-premises infrastructure. And we'll talk about how we can do all of that in this session. And that's what this session is about. Cool. So this gives you a sense of the AWS global infrastructure. We've got 32 regions. There are a lot more announced. We have 115 Direct Connect locations. We've got over 400 edge locations. And I'd say that this is the backdrop, right, in terms of what we need to consider for building hybrid connectivity. So it's not only kind of that complexity in terms of your existing enterprise networks, but the questions now are, when you build in the cloud, when you deploy, when you create new workloads, what's the strategy there? Is it multi-region? Is it multi-VPC? You know, kind of what's your approach? And so what we'll talk through now is how we can cater for kind of all of those different models. So to start with that, what you might begin with is that you've got data centers, right? So those are the data centers on the right. And we want to get those existing data centers connected to AWS. So the one way that we can quickly get going is to leverage AWS Site-to-Site VPN. So Site-to-Site VPN allows you to create encrypted IPsec tunnels from your data center to AWS in minutes. With each site-to-site VPN, you get 2 tunnels, which connect back to AWS. And to that one virtual private gateway that gets those data centers connected to your first VPC. For those who that's where you define your private subnets that you want to operate in AWS. And then if we want to connect to another VPC, well, we create another set of tunnels. We connect to those virtual private gateways. And that's that one-to-one relationship that I mentioned, right? And it's also just important to understand that for each site-to-site VPN that's got those 2 tunnels, each tunnel supports a maximum throughput of up to 1.25 gigabits per second. And then if your VPN connection is to a private gateway, aggregated throughput limits also apply there on that private gateway. So moving forward, we want to connect out more VPCs to other regions. We've got to do it again, right? So the virtual private gateway, that could be a pattern you may want to consider. If you don't necessarily need to scale out too much, you can connect from a site directly to a VPC using that. But if we want to now scale that out, one of the ways that we can do that is a number of years ago, about 4 years ago, we introduced the AWS Transit Gateway. And that's effectively kind of a cloud scale router that lets you simplify your networking across many VPCs. So how would that work now with these data center connections? Well, what you do is the VPN termination endpoint would be attached to that AWS transit gateway. And now you don't need to set up separate connections to each VPC. You just leverage the site-to-site VPN through the transit gateway, and that way you can get to multiple VPCs. And then this way, you can also overcome that limitation around the 1.25 gig, right? So now what you can do is you can actually aggregate data across those tunnels, and you can achieve higher speeds. So that's the way that you can now scale your site-to-site connections to multiple VPCs. And it's also important to know that that transit gateway operates at a regional level. There are kind of more advanced patterns you can look at, but if you wanted to connect those data centers to each region and to multiple VPCs in each region, this is one of the ways that you can do that. Cool. So we've connected our data centers. If we think back to that kind of big, complex enterprise network mesh we saw earlier, we've simplified that a little bit by connecting our data centers to AWS. Now, what we're possibly thinking about is remote branch offices. So they could be located all over the world. In this instance, they're in the EU and they're in the US. And how we can do this is, again, using the site-to-site VPNs. But what I'm going to focus on now is what if we need very reliable and very consistent performance. What you're seeing here is you're seeing that those site-to-site VPNs connect to AWS. We're using that transit gateway approach that I spoke about earlier. So that's the one path for the one VPN tunnel. This would be the second path for the second VPN tunnel. As I'm sure you're aware, and as I'm sure Yolandi would be happy to explain to you, paths across the internet could traverse multiple ASNs. And what that means effectively is that if there's any sort of outage or interruption, such as with that AS that's gone red, we don't really have much control over how that path is going to reroute. So that could result in higher latencies, it could result in inconsistent performance, any number of kind of disruptions or challenges. So one way that you could mitigate that is by clicking a button when you provision your site-to-site VPN. And what that button click could do is help you by leveraging the AWS Global Accelerator service, which provides you with static IPs that we effectively anycast to you. And then that means that when you connect your site-to-site VPN, you're connecting to the nearest and always the nearest anycast IP. And we then manage the traffic across the kind of almost an edge backbone to get it back to your VPC via your transit gateway. So that would give you much more kind of consistent and improved performance. And as you can see in the connection, when you configure it and set up your site-to-site VPN, it's a tick box to enable that service to give you improved performance there. So that's cool. We've connected our data centers. We've now connected our branch offices, but what about your workforce? So for that, we've got the AWS Client VPN. You can connect using either an open VPN client. We also do have our own AWS VPN client that's available for various operating systems. And how that works is that we first create a VPC for your client VPN service. That's kind of like your target VPC that your users would connect into. You create a client VPN endpoint, and that creates associations in your client VPC. And what that effectively does is it spins up kind of elastic network interfaces, which you'll see in a moment. Now, before you provide access to the resources for your users, you do also have various authentication options. There's mutual authentication using Certificate Manager or user-based authentication, AD, SAML for user federation. And then once you're authorized, your clients will effectively connect through those ENIs that get provisioned to your resources. And what you can see here is that they connect via the transit gateway, and basically your users are kind of source natted. It's almost like a NAT overload via those ENIs, source NAT there, and then you can also configure kind of authorization. Whoops, let me go back 1 sec. Configure authorization rules for those users, for those resources. And that, in a nutshell, is how you can enable your workforce, remote users, to access your environment on AWS. And then that now takes us to physical connectivity. So let's say you have moved more workloads onto AWS, or you have a particularly kind of high bandwidth requirement for migrations. And so the kind of high speed, high performance, consistent performance option, what can you do? Well, you can use physical connectivity using AWS Direct Connect. So Direct Connect is a service that has 115 points of presence. I think I mentioned that earlier, across the world, where you can connect your physical data center with an AWS Direct Connect location with an actual kind of physical connection. Your router could be on premises at your own data center, or it might be already co-located at an AWS Direct Connect location, such as Teraco. And Direct Connect helps you connect to public services like Amazon S3, as well as VPCs using what we call virtual interfaces. There's multiple virtual interface types, which we'll cover in a bit. But the concepts of Direct Connect are basically, one, the physical connection. That physical connection is the actual connection you set up between your device on premises or co-located and the actual AWS side device. That physical connection can be 1 gig, 10 gig, or even 100 gig at select locations. And in 2017, we announced the Direct Connect Gateway, which allows for you to span across VPCs, across multiple regions. So you don't necessarily need to, sorry, I've gone a bit far in my deck. You don't necessarily need to spin up multiple BGP sessions to each VPC. You can just connect to the Direct Connect Gateway and then run virtual interfaces across that. We also in 2021 added MACsec, or Media Access Control Security Standard, to support hardware-based encryption, which brings a number of benefits between your router and AWS's on 10 gig and 100 gig connections. It is important to note that that is in select Direct Connect locations, however. So if you don't have presence in a Direct Connect location, what can you do? Well, one thing you can look at is leveraging a Direct Connect partner. That Direct Connect partner would take care of everything along the way, so to speak. And then they'll just provide you with effectively like a layer 2 circuit. And in this case, you'd still need to offer up a physical port from your on-premises router at your data center location that your Direct Connect partner can connect to. But the Direct Connect partner will operate and maintain any physical equipment kind of sitting at the AWS Direct Connect location along the way. So to kind of expand that out, we can see that the Direct Connect partner has their own network. They have their own equipment co-located with AWS, and they'll just provide you with a layer 2 circuit, and then the layer 3 will effectively operate between your on-premises. We'll go into that logical connectivity in a moment. And these hosted connections go up in increments 50 meg, 100 meg, 200 meg. And this type of connectivity in a number of different ways, and Kavir will cover those in a few slides. I'm just going to build out how this works. You can those are the speed increments, and that's basically how the Direct Connect hosted connection works. So how does the logical connectivity work over the physical connections? Well, I mentioned a little earlier that there were things called, basically it worked a little differently before the Direct Connect gateway that we introduced. Before that, you had to establish multiple BGP sessions for each VPC, but now you effectively connect to that Direct Connect gateway and then establish the virtual interfaces. They're effectively VLANs to your Direct Connect gateway from your own router, and then you establish the eBGP with that Direct Connect gateway. And then from there, you create associations between the Direct Connect gateway and your transit gateways, and that's how you get to your VPCs via the Direct Connect gateway. Those are the virtual interfaces or VLANs, and there's the BGP session that you would get to establish. So briefly, what are those virtual interfaces? What types of virtual interfaces do you have? There are three different types. Virtual interfaces, as mentioned, kind of like a VLAN, basically a slice of the physical connection. And the first type of virtual interface is called a private virtual interface that allows you to connect to your VPCs and private resources in AWS. Think your private subnets, your own private address space that you've allocated for yourself within those VPCs. And then that's basically how that connects out. So you can see Direct Connect Gateway to those VPCs. Then the second type is your transit VIF. So interface used in you can have up to 6 transit gateways associated with connected to the Direct Connect gateway. And then the last type of virtual interface is basically your public virtual interface. That to services like Amazon S3, Amazon DynamoDB, and other services that have public endpoints, because everything outside of, basically everything outside of your VPC. For this VIF, there's no special gateway to use. It effectively lands in AWS directly. And I'll quickly show you what that looks like before I hand over to the much more competent solutions architect on this call, Kabir. So here we go. This is the public VIF, and it's pretty much as simple as that. When you deploy public virtual interface, connectivity is established to AWS, and then we'll advertise around 3,500 AWS prefixes back to you. And now I'm going to hand it over to Kabir, and Kabir is going to explain some of the kind of nuances and considerations between dedicated versus hosted connections, and then go into a few more advanced patterns with you. Cool. Kabir, over to you.
Thanks for that, Peter. Are you going to continue to share, or would you prefer for me?
I'll stop. Well, I can share for you if you want the burden of telling me when to click, or you take over the screen.
I think it'd be easier if let me take over the screen share.
Okay, sure.
Need you to Peter, I just need you to stop sharing first.
All right.
There we go. Perfect. I'm just not sharing there. And okay. Can you see my screen?
Yes.
So, as Peter alluded to earlier, we have two different ways to connect using Direct Connect. The one is using dedicated connections. So in Johannesburg, we have in South Africa, we have 2 locations, the one being Teraco Rondebosch in Cape Town, and the second one being Teraco Isando in Johannesburg. So those are the 2 DX locations that we have, where you could leverage both the dedicated connections and hosted connections through partners like the Africa Cloud Exchange at the Teraco facility. With the dedicated connection types, we have different port speeds, so you can connect with 1 gigabit, 10 gigabit, and today 100 gigabit is not available at those locations, but if customers do have a requirement, please reach out to us so that we kind of work backwards from customers on those requirements, and that helps drive the request to bring those in region. Over the Direct Connect, you can now support, initially we used to only support 1 transit VIF per dedicated Direct Connect connection. Today, we've increased that limit to support up to 6. So we've extended the capability quite significantly. On the hosted connection side, we provide customers with a lot more flexibility via our partners. So you have the ability to connect up with speeds of between 50 and up to 10 gigabits per second. And those SLAs are driven typically through our Direct Connect partners. You have the option to leverage both transit and private VIFs, but the most common pattern is generally leveraging transit VIFs for 1 in 10 gigabit type connectivity. A call out for around site-to-site VPNs. So in certain scenarios, customers would like to be able to connect through to their workloads for end-to-end encryption. They have the ability to be able to leverage the public VIF and build an IPsec tunnel, as Peter explained in some of the earlier slides, leveraging that public VIF to be able to build that IPsec tunnel over the public VIF. Now we're going to go into some of the resiliency capabilities and how we provide different levels of high availability. So today, for example, if you wanted a high available Direct Connect solution, what would happen is from your customer router, you would go and procure links from your ISP to 2 separate Direct Connect locations. So that would be in South Africa, this would be Teraco Rondebosch, for example. This would be Teraco Isando. And from there, you would order 2 separate cross connects at each of those locations through to the AWS routers. And those would then connect to a single AWS Direct Connect gateway, which would allow you then to connect to multiple AWS transit gateways in different regions. For example, you could have this in the AF South one, which resides in Cape Town, and another region, for example, Ireland. For a maximum resiliency perspective, if you wanted an SLA of 4 nines of high availability, of maximum resiliency and high availability, the AWS recommendation is to start by initiating those 2 separate connections to 1 Direct Connect location, which you would then terminate on 2 separate AWS routers at that Direct Connect location. So this provides for both path and device redundancy under failure conditions. And the pattern would then be similar. So from these AWS routers, you would connect all of these to a single AWS Direct Connect gateway, then connecting them up into the transit gateways in the different regions. If we wanted to be able to control traffic over the different direct connect locations, whether it's for different regions. AWS provides a few different mechanisms to be able to identify how you would like us to steer traffic through to your corporate data centers, leveraging BGP communities. The higher the BGP, the higher the community, the preferred the path. So in this particular scenario, if you wanted to be able to send all traffic via the direct connect location 1, we would choose the BGP community with 7300, which has the higher preference. If you wanted to control how AWS would, you would send traffic to AWS. You have the ability on your routers to be able to select the local preference for the routes that you learn from AWS, allowing you to traffic engineer in both directions. We also have the capability to leverage ECMP. So if you don't set any of these BGP communities, what would happen is we would consider all paths connected to this direct connect gateway as equal, and traffic would be load balanced across all of the different active paths. We've also introduced a new feature called AWS Direct Connect Site-Link. What Site-Link provides the capability is to use the AWS backbone as a transit between your different data centers. So previously, when you configured an AWS Direct Connect, we would prevent you from sending traffic between your different data centers. Now, with the addition of AWS Direct Connect Site-Link, you have the ability to edit those links. And with a single click of a button, you can enable AWS Site-Link, which then gives you the capability to route traffic leveraging the AWS backbone between your different corporate data centers. So if we look at what it takes to build modern WAN, but on a global scale, we see more and more requirements. I think Peter pointed out a few of those earlier, the requirements for different branches, users. And as we go to become, people tend to work from home, remote, in different geographies. How do we extend our WAN capability to be able to expand into different regions, peer those regions, provide connectivity for the different workloads? You start out with building out, for example, if you have workloads in Asia, North America, and Europe, where you would need to connect up your on-premise data centers through to these different regions. But that scale needs to take into consideration connecting branch connectivity and end users in different regions. This creates complexity for customers. So with that, AWS introduced something called AWS Cloud WAN. And the idea behind Cloud WAN was, as customers started to run workloads in multiple different geographies, Cloud WAN provided a mechanism to be able to provide SD-WAN type connectivity. So connectivity from different branches, from client VPNs, warehouses with site-to-site VPNs, direct connect links, all into a centrally managed solution called AWS Cloud WAN. What AWS Cloud WAN allows you to do is to connect up all your different workloads in the cloud to all these different edge locations. what we also allow for within Cloud WAN is to be able to segment the traffic into different tiers, so you can isolate traffic and the connectivity patterns for each of those, whether it be development, if you want to segment production and testing, or this is one particular pattern for segmentation. You can think of doing these patterns, whether it's, per business unit, per workload, per organizational structure. They're one of many patterns that you can use for the segmentation of the traffic. With the hybrid connectivity model for these workloads, we also have the ability to be able to attach client VPNs, your AWS Direct Connect, and third-party SD-WAN WAN solutions. So if you look at things like the Fortinet, Palo Alto, Cisco's Meraki solutions, those are all services that integrate with the AWS Cloud WAN. The benefit there is that you can still leverage the AWS backbone while leveraging connectivity mechanisms that you have that reside on-premise today. The way we terminate some of those links is leveraging the AWS Transit Connect gateway with GRE and BGP. But there are also specialized solutions that we do have from some of the third-party providers. So how do customers migrate from a traditional approach where you had a transit gateway into an SD-WAN environment? What we allow for is the ability to be able to transition fairly easily from a transit gateway type approach where you have multiple different route tables. For example, you'd have a route table for production, for testing, for development. With the creation of a Cloud WAN, you have the ability to attach the VPC directly into the Cloud WAN and create the segment specifically on that. So that would allow you to be able to transition fairly easily between the different services. One of the key benefits of Cloud WAN is the networking policy. There's a centralized version-controlled policy that you can define for each. What happens is you need to define each of the edge locations. These are typically the points of presence, or what we call a virtual POP within AWS. So you define you would define where these edge locations are based on where you'd have your workloads. And once you've defined those edge locations, for those edge locations, you can then attach one or multiple different segments to each of those edge locations. And then within the segments of those workloads, you can control the CIDRs and how those CIDRs would communicate between the different edge locations based on the segment. So you have a clear fine-grained policy typically done at a layer 3 level, or you can leverage things like tagging policies to identify the different environments. So with Cloud WAN, you have the ability to segment based on IP addresses and subnets, but you also can leverage things like your metadata to do some of that segments, VPC IDs, attachment types, account IDs, or specific regions. And you can combine, so the additional capabilities, the ability to combine those different. So you can combine subnets with metadata or regional information to be able to segment up the traffic and provide connectivity between the different environments. We also support a mechanism to be able to have shared segments. So if you have an environment where you have certain patterns where multiple different environments like production, development, and testing all need to connect into a shared environment, we also support that capability as well. With Cloud WAN, we also support a multi-account structure. This allows customers to be able to define the core of the Cloud WAN in a centralized networking account, and then leveraging a service called the AWS Resource Access Manager to be able to share that core network with the different AWS accounts. So what would happen with that? You define the core network resource, then share it. Once you've identified the core network, you can then have the ability to share that with the individual accounts. They would then attach they would then provide attachments into the individual accounts. So what would happen is with that, you would say this AWS core network would then be shared at a specific edge location and attach it into specific VPCs in the individual accounts. What we also have is a hybrid DNS with Route 53. What this provides for is a seamless connectivity from DNS resolution perspective between your on-premise environment and the AWS environment. What we have are what we call resolver endpoints. These allow for workloads within AWS to leverage the outbound resolver endpoints to resolve DNS from your on-premise data center environment. So that simplifies connectivity of resolution of any workloads that reside on-prem. We would create a forwarding rule on the Route 53 resolver and says, for this particular example, anything that's example.com internal, send that out through this AWS outbound resolver endpoint. The traffic would be forwarded then through to the DNS resolver that resides on premise. We also have the ability for on-premise to be able to resolve traffic using an inbound resolver. So what would happen is on your on-premise DNS, DNS resolver, you'd set up a forwarding rule. It says anything for the 10 range, for example, or example.cloud would be forwarded through to the inbound resolver that would then be resolved within the VPC. On AWS side, we have something called AWS private hosted zone. So you can then do cloud native DNS resolution and define rules both for CNAMEs or any of the other record types. Those are defined and attached on a per VPC basis. So you can have multiple different private hosted zones attached to each of the individual VPCs and define how those would be resolved within the VPC. And I think that's an example of how the resolution would work. And just, I think for a quick recap, between Peter and myself, we've covered some of the key AWS connectivity mechanisms. If you as a customer are starting out in your journey, where would you start out? The first thing I would do is start out with a site-to-site VPN. It doesn't require the longer lead times of a direct connect. For your remote workforces, the simple thing would be to focus on an AWS client VPN. As you start to scale the environment, you can kind of think of leveraging AWS Direct Connect. That comes with the two options of dedicated connectivity or a hosted connection, leveraging our AWS partners. We also have different resiliency patterns in that. So you can start out with a single direct connect link for your dev and test workloads, evolving that to a high available solution, connecting to multiple different DX locations. And then obviously, as you need to scale that environment out into a maximum resiliency model. For connectivity that requires low latency or connectivity between your different your branch sites, think about leveraging AWS Accelerated VPN for optimal latency, for the direct connects, for connecting up your branches and leveraging the AWS backbone. And then for simplifying all the orchestration and management of a lot of this workload, you can think of leveraging AWS Cloud WAN. Thank you. I think I'm going to stop there. Handing over to you, Peter.
Cool, thanks. Frantically trying to find the mute button, as always. I think half my life is trying to find the mute button. Cool. Thanks so much. I'm going to quickly. There was a question, Kavir, around Cloud WAN and PGW. If you want to check that in the Q&A panel.
Yep.
Might want to just talk to that briefly. I did give a short answer. I'm also going to share my screen again quickly because what I'd love everyone on the call to do, if you don't mind, is just fill in the survey. I'm also going to share the link with everyone on the chat if I can find it. Chat.
Yeah.
So it's very important, hosts and panelists. It's very important, for us to kind of do better with these things in the future. That we get feedback from you, so we know how to kind of adjust or pivot. Is this useful? Is this something you think we did well? Was it an absolute disaster? Was Peter an idiot? These are all useful questions to get answers to, and I'd love for you to fill in the survey. I'm just going to see, can everyone see the chat?
I can see your screen, Peter. Sorry, it's Mark here from NAP Africa team. So just before everyone jumps off, I also want to just go through some of the Q&As that was posted, because I don't think all the attendees got privy to see that. Just so we can just quickly discuss that as well. Just some of the, I see you did answer everything on the line already. So,
yeah, sure. I think the one question was, can you have both a transit gateway and Cloud WAN in your environment? Absolutely. So I've got a lot of customers who have both those in their environment. So they use Cloud WAN, for example, for connecting their branches and their internal network, but they also have a lot of third-party connectivity, and they leverage the transit gateway to simplify the third-party connectivity. So it's not a either or, it's an and type scenario. You most certainly can use both of them. I think the use case to think about is, if you want to administer everything in a single place, the Cloud WAN is generally better. But if you've got different third-party requirements, transit gateway tends to be a better approach in a lot of those scenarios. There was another question around multicast support. Yes, the Transit Gateway does support multicast. The only thing with multicast is that when you create the Transit Gateway, you need to enable multicast before you create the Transit Gateway. It's not something that you can do post the creation of it, because the multicast groups need to be initialized when the Transit Gateway is created.
Thank
There
you,
was
Kabir. I'm just looking at some of the questions that was answered and already. I think the first one was, do you support MACsec in South Africa? Yourself and Peter also answered that already. But if you can just maybe share that with the rest of the attendees.
Sure. So today we don't support MACsec in country, but Amazon is a company that kind of works backwards from our customers' requirements. And if that's something that's really burning and a lot of customers need, please feel free to reach out. I'm part of the technical field community for networking at AWS, and that kind of feedback helps me justify why there is a requirement from customers for that. So I'm more than happy to take that. I think Peter does put up a slide with my email. Please send me that requirement, and I'm more than happy to try and drive that from that perspective.
Thank you. Next question was Direct Connect to Teraco JB2. So that's Bradell, for those that don't know. Peter answered that already. He says, unfortunately, only at the following locations today is Teraco Cape Town and Teraco JB1 Asando. And he's also put a document there where you can see the location. So I will put that in the chat as well for everyone to see. The next question was, does AWS Direct Connect support BYOIP? Which Peter also answered. Peter, if you just want to maybe just give a short answer on that.
Kabir probably knows more about the
intricacies
of bringing your own IP to AWS, but there are some useful links.
The question I'd ask on bring your own IP over Direct Connect, over the public VIF, today you are welcome to advertise your own IP address spacing. What bring your own IP address as a use case would typically be is if you wanted to use your own IP addresses on AWS on workloads like EC2. So we definitely do support that. So you'd need to get permission from the registry to be able to a letter from the registry to say you are the authoritative owner of that IP address space, and then we would advertise that IP address space on your behalf out of the AWS global backbone for workloads that would reside in AWS. But yes, we do support that, and that is for both IPv4 and IPv6 address space.
Cool. Peter, I see you asked me for that the Pulse link. I'll share it as well for everyone to see. I don't see any further questions at the moment there. If there's any further questions, just going to find the Pulse link. I think you did share it, Peter, so I think everyone got it, but I'll just repost it as well. There you go. And that's it. Gentlemen, thanks so much for your time, Peter and Kabir. Very informative session, as always. For all the peers and networks joining, appreciate your time. We will also share this presser. It was recorded. So thanks for everyone, and just look forward to your next Tech Days. Thanks, guys.
Thanks. Cheers. Bye.
Thank you,
Cheers. Bye-bye.
Bye.